This is on the properties of quadrilaterals, at least the properties of the 7 specific or special quadrilaterals we're going to talk about in here. So parallelograms, rectangles, squares, rhombus, trapezoids, isosceles trapezoids, and kites. So first thing we want to know about this one, because we're going to use this a lot. Okay, we're going to have to solve problems, solve for different angles and sides, variables in the problem. So we need to know how to use this reference sheet, and we need to know what the properties for each one of the 7 special quadrilaterals is going to be. Okay. So first thing you should notice, we'll talk about is that it's a Venn diagram. Okay. So I have it zoomed out just so we can still see the whole thing. We're going to zoom in on specific pieces going forward, but let's look at the overview first. So up here we have parallelograms. And in the introduction to quadrilaterals, we talked about how rectangles, squares, and rhombuses were parallelograms. Parallelograms were defined as having 2 pairs of parallel sides. And we notice rectangles, squares, and rhombuses have 2 pairs of parallel sides, so they are going to be parallelograms. Okay, right? That's why, again, here's this blue box in your reference sheet. Right, outlines, again, a Venn diagram, right? So everything inside of this line, this circle, box, circle-y thing, whatever you want to call it, it's not quite a circle, it's not quite a box. A rounded off box, I guess. Everything inside is going to be a parallelogram. That means it entirely contains the circle for rectangles, the circle for rhombuses, okay, and then the circle for the square. So every rectangle, every square, every rhombus is a parallelogram. So if you look at the properties of a parallelogram, they are all going to apply to everything in this rounded square, rounded box. Okay, so all these properties apply to rectangles, squares, and rhombuses. Okay, then the same thing is true for the square. So the square, if we look at the rhombus box, everything for the square is contained within the rhombus box. So if it applies to the rhombus, it applies to the square, because a square is a rhombus. Remember, a rhombus is defined as having 4 congruent sides. A square also has 4 congruent sides, so a square is a rhombus. Okay. For the rectangle, a rectangle is defined as having 4 right angles. A square has 4 right angles, so all squares are rectangles. Okay, but again, not all rectangles are squares. You can have rectangles out here, right, that are not squares, right? They don't have all 4 sides. Because a square needs to be a rhombus and a rectangle. It needs to have 4 congruent sides and 4 right angles. 4 congruent sides, 4 right angles makes it a square. Okay, then down here we have our other 3. So we have trapezoids. But trapezoids are defined as having exactly 1 pair of parallel sides. And then isosceles triangles or isosceles trapezoids go 1 step further. So like isosceles trapezoids, we had 2 congruent sides. The isosceles trapezoid is going to have 2 congruent sides. So the legs, what we call the legs, are congruent. And then the kite, it's quadrilateral because it has 4 sides. But it's not going to be a parallelogram. It's not going to be a trapezoid. So we're going to put it in its own box. Okay. Let's focus on the properties of the parallelogram. So we put zoom in on the parallelogram portion. So parallelograms are defined by having 2 pairs of parallel sides. That happens to be our first property. Since this already has everything, I'm going to try to draw things individually so we can see what each one individually is talking about. So 2 pairs of opposite sides are parallel. So that means this side is going to be parallel to the opposite side, the side across from it. These would be consecutive sides. These are opposite sides. Consecutive is right next to one after the other. Opposite means across from. Okay. And then our other pair of opposite sides. Right, 2 pairs of opposite sides. Here's 1 pair of opposite sides that are parallel. Here's a second pair of opposite sides that are parallel. And again, I'm going to erase this just to show each property individually, because this diagram shows all the properties together. You guys have this reference sheet, and we can see it here. Okay, so if it's not big enough, just look on your own sheet. But this has all the properties on it. I'm just going to draw them one by one. So that was two pairs of opposite sides of parallel. Okay, two pairs of opposite sides are congruent. So opposite sides are congruent. That's one pair of opposite sides that are congruent. Here's a second pair of opposite sides that are congruent. Right? We see that on this diagram. One pair of opposite sides congruent, denoted by the hash marks, and then two pairs, the second pair of parallels of congruent sides by the two hash marks. Again, the arrows represent the parallel. So these lines are parallel. These lines are parallel because of the arrows. The arrows are the symbols we use. Two pairs of opposite angles are congruent. Okay, so we begin A, B, C, and D. All right, we want to name our quadrilateral. We would name it A, B, C, D. You just go in order, A, B, C, D. Okay, it could be B, C, D, A. It could be A, D, C, B, C, B, A, D. As long as you're going in order, as long as you're going to consecutive vertices, consecutive angles, the ones that are right next to each other. C, B, A, D, D, C, B, A. Okay, we can't go C, A, D, B. We can't name it C, A, D, B. That would be a different, if we named it C, D, A, B, it would look something like this. So it wouldn't be one of the four. It would be a quadrilateral. But it wouldn't be one of the quadrilaterals we're talking about. So opposite angles, what's opposite angle C? It's going to be, opposite angle A is going to be angle C, across from. Okay, opposite angle D is going to be angle B. So two pairs of opposite sides are congruent. Consecutive sides are supplementary. Okay. So again, we know that these two sides are parallel. So we notice we have angle A and angle B are same side interior angles. They're both on the same side. If AB would be our transversal. BC and AD would be our parallel lines. AB would be our transversal. So they are on the same side of that transversal, and they are both on the interior of the two parallel lines. So they are same side interior angles. We know by the same side interior angle theorem that same side interior angles are supplementary. So these two angles would add up to 180. Okay, if this was 60 degrees, this one would have to be 120 degrees. We also know that AB is parallel to CD by our first properties, that two opposite sides are parallel. So we know these are going to be same side interior angles that are supplementary. Right? Since the lines are parallel and the same side interior angles are going to, since the lines are parallel, the same side interior angles are going to be supplementary. Therefore, if that's 60, this one's going to be 120. Right? If we look back at our property before that, opposite sides are congruent, 120 and 120. And then C and D are going to be supplementary, and B and C are going to be supplementary. So either way, we're going to have 60, and then our opposite angles are going to be congruent. Okay, so, if you think you have to memorize all these, right, you really don't. Right? They all go with each other. So it's not a matter of memorizing a bunch of facts. It's about understanding what's going on. It's about knowing the basic definitions we have. You don't need to memorize a whole lot to know a whole lot. Okay. And then the last one, diagonals bisect each other. Okay. So again, if we name it A, B, C, and D, the diagonals, again, this is terrible. This is a diagonal. It goes from one one vertices to the opposite vertices. Right? Consecutive is right next to, so A and D are consecutive vertices, and C would be opposite vertices. Okay, and then BD, the opposite vertices. So those are our two diagonals. That's what a diagonal is. It goes diagonally. It goes diagonally relative to the parallelogram. Okay. And what's saying they bisect. So we talked about bisect before, but you guys still aren't totally on board with the idea of bisecting, which is concerning, but let's try and fix it now. Okay, you have diagonals, they bisect each other. So let's say they intersect at point E. So our diagonals are AC and BD. So AC and BD bisect each other. So if AC bisects BD, that means it splits BD in half. It splits the segment BD into two congruent segments. So the place where they meet is E. So E is going to split segment BD in half. It's going to split it into two congruent segments. So BE is going to be congruent to ED. And we also have AE, right? So now BD is going to bisect AC. Okay, so AE is going to be congruent to EC. Diagonals bisect each other. And again, all this is in our diagram. Okay, consecutive angles are supplementary. Diagonals bisect each other. Okay, denoted by the 3 hash marks here and the 4. So rectangle. Okay. Again, rectangles are defined as having 4 right angles. Okay. Rectangles are perpendicular, or they are parallelograms. So all 5 of these properties, okay, they all apply for rectangles because rectangles are parallelograms. Therefore, they have the properties of a parallelogram. Okay, but with rectangles, we're adding 2 additional properties. The diagonals themselves are congruent, and the right angles are congruent. Okay. So if this is our rectangle, A, B, C, D, rectangle A, B, C, D, the diagonals, so AC and BD, AC is going to be congruent to BD. The diagonals have the same length. Okay, and then our defining property of the rectangle is that all angles are right angles. So not the angles with the diagonals, it's without the diagonals. So these are diagonals that are congruent. Okay, and then again, we define a rectangle as having 4 right angles. So this is a parallelogram because it has the properties of parallelogram because rectangles are parallelograms. So it has 2 pairs of opposite sides that are parallel, okay, but we also classify it more specifically as a rectangle. So if you're ever asked for the best description or the best classification of this diagram, it's going to be a rectangle. It is a parallelogram, but rectangle is the best description of it. Then we also have rhombuses. So again, a rhombus is defined as having 4 pairs of congruent sides. That's how we define a rhombus. Okay. But if you notice in this diagram, we see the other 2 properties it has besides having 4 sides that are congruent. It has diagonals that are perpendicular. So if these are our diagonals, so this is A, B, C, D, we're going to form 4 right angles, right? That box around there is really 4 right angle symbols. Okay, we're forming 4 right angle here, 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 and here. 4 right angles. The diagonals are bisect each other. Again, bisecting. They're perpendicular. So the diagonals bisect each other because rhombuses are parallelograms. Okay, but they're perpendicular because they are that's one of the properties that emerges from being a rhombus. Okay, rhombuses are defined as having four sides that are congruent, but one of the other properties that emerges is that the diagonals are perpendicular, meaning the diagonals. So AC and BD are the diagonals. They are lines that go from the two opposite vertices, connect the two opposite vertices. They are perpendicular, so they form right angles where they meet. So we have four 90-degree angles here, four right angles. The other one is that they bisect opposite angles. Okay, they bisect opposite angles. So that means they split these in half. Okay. So these are congruent. So angle BAC, angle DAC are congruent. Angle BCA and angle DCA are congruent. And then we also know angle CBD and angle ABD are congruent, along with angle ADB and angle CDB. So they bisect, they split the angles in half. Angle A is split into two congruent segments. Angle B is split into two congruent segments. Angle D is split into two congruent segments. And angle C is split into two congruent segments. And again, notice we have triangles here. So we could have reflexive property on AC, and then we could say our triangles ABC and ADC are congruent and do all sorts of things with that. Okay, the fourth parallelogram we have is the square. So again, squares are both rhombuses and rectangles. Rectangles are defined as having right angles. So squares have right angles. Rhombuses are defined as having four congruent sides. So squares have four congruent sides. So all the properties that apply here and here apply to the square. All the properties up here apply to the square, because squares are rhombuses, squares are rectangles, and squares are parallelograms, right? A square is part of the rhombus box, part of the rectangle box, and it's all within the parallelogram box. So squares are parallelograms, rhombuses, and rectangles. Okay, but the best description for a figure like this that has four sides that are congruent and four angles that are congruent is a square. The best description is a square. So it has all 10 of those properties listed. Two pairs of opposite sides that are parallel, two pairs of opposite sides that are congruent, and so on. Diagonals that are congruent. So that's the first four. If we go down to the next three, we have trapezoids and kites. So parallelograms are defined as having two pairs of parallel sides. So all the figures we just talked about have two pairs of parallel sides. If the figure only has one pair of parallel sides, exactly one pair of parallel sides, exactly one, then we're going to call it a trapezoid. So this green box, okay, that is where our trapezoids are. Again, this big black box is quadrilaterals. You have the parallelograms within the quadrilaterals, but separate from the parallelograms, you have trapezoids and kites. So again, the defining aspect of a trapezoid here is the parallel sides. So again, if we have A, B, C, D, trapezoid A, B, C, D, AB is going to be parallel to CD. That's the defining characteristic. The other property we have is that consecutive angles between bases are supplementary. So again, I don't think we mentioned in this video, but in the introduction to quadrilaterals, we talked about bases and sides. So if we have a trapezoid, I'll put it here. This is a base. This is a base. And then these are legs. Okay, so it's saying consecutive angles between bases are supplementary. So consecutive, meaning right next to, between bases. So the consecutive one, so we have two consecutive angles here and two consecutive angles here. Okay, But we want the consecutive angles that are between the bases. So here's the bases. Okay, A, B, and DC are the bases. So what angles are consecutive in between the two bases? It's going to be right here, and here, and then this one and that one. So angle A and angle D are going to be supplementary because they are consecutive, meaning they are right next to each other, and they are between the bases. Angle B and angle C are going to be supplementary, meaning they add up to one. The measures add up to 180 because they are consecutive. They're right next to each other. They go in order, like 4 and 5. What comes after 4 or 5? What comes after B? C. So B and C are consecutive, and they're between the two bases, so they're supplementary. Okay, if we notice, A and B are also consecutive, but they're not between the two bases. They're between the two legs. Right? If we look at A and B, okay, these are consecutive. They're right next to each other. They go one after the other. A comes before B and B comes after A, or vice versa. So they're consecutive. They're right next to each other. Okay, but the key here is they're not between the bases. Our bases are the sides that are parallel. So in this case, it's AB and DC. So they are not supplementary because they are not between the bases. Okay. The subcategory of trapezoids we have are isosceles trapezoids. So isosceles trapezoids are trapezoids. So these two properties apply to the isosceles trapezoid because this box is light blue, teal coloredish box is within the green box. All right, and this is a Venn diagram. Okay. But then our isosceles trapezoid has a bunch of additional properties. So again, we have the basics here. We have the parallel sides. Okay, I'm going to label again this A, B, C, and D. Exactly one pair of parallel sides. So we have exactly one pair of parallel sides, A, B, and C, D. Which they wrote again for us, just so we're blatantly clear. Okay. Then it says both base angles are congruent. Okay, so again, AB is a base, DC is a base, and then AD is a leg, and BC is a leg. Okay, the base angles are angle A and angle B. Right, the other base angles are angle C and angle D. Those are base pairs. So this is one set of base angles, A and B, because they are both on the first base, which is AB. I don't think I wrote this big enough, but you won't be able to see it over the other stuff. Okay, and then CD is the other set of base angles. So we know base angles are congruent. So angle D is congruent to angle C, and angle A is congruent to angle B. Opposite sides are supplementary. Opposite sides are supplementary. So base angles are congruent. Right? The reason opposite sides are supplementary are because consecutive angles between the bases are supplementary. So A and D are consecutive bases, consecutive angles between the bases. Since the consecutive angles between the bases are supplementary, right? Since angle D is supplementary to angle A and angle C is supplementary to angle D, right? We can use substitution there, right? We can substitute in C for D and A for B, and we can get that D and B are also going to be supplementary. So we don't need to worry about the going through all those steps. That might be confusing for a lot of you. We're just going to say angle D and angle B are supplementary. One pair of legs are congruent. That's the big defining characteristic of the isosceles trapezoid. Okay, this is the one you want to look for when looking for an isosceles trapezoid, that these legs are congruent. So in this case, AD is congruent to BC. Then we also have that diagonals are congruent as well. Okay, so 5 additional properties there. Diagonals can go in from one to the other. So BD and AC. Okay, 2 consecutive sides are congruent. So the third, so we have Parallelograms, two pairs of parallel sides are congruent. Trapezoids, exactly one pair of parallel sides are congruent. And the case we're going to talk about where no parallel line, there are no sides of parallel lines that are opposite sides that are let me start over. There are no opposite sides that are parallel. There are no pairs of opposite sides that are parallel. Okay? And that's when we're going to have a cut. And there's obviously lots of other cases where no opposite sides are parallel, but the one we're going to focus on is a kite. So a kite, again, is defined as having those disjoint consecutive sides that are congruent. Okay, it's basically like saying there's two sets of congruent consecutive sides that aren't congruent to each other. So two sets of congruent sides that are consecutive. Two sets of consecutive congruent sides. Okay, two pairs of consecutive sides are congruent, right there. I didn't need to stumble over my words. I could have just read it. So again, if this is A, B, C, and D, AB is congruent to BC. Okay, that's one pair of consecutive sides, and this is the other pair of consecutive sides. Okay, AD and CD. This is another one where classification can get confusing because we're talking about disjoint or non-disjoint. You can see both types of definitions. You can see times where people say kites can be rhombuses, but this is the definition we're going with. We're going with the disjoint one, where we have two sets of separate consecutive sides that are congruent. Okay, one pair of opposite sides are congruent. So in this case, it's going to be angle A and angle C. So let me draw that one out. Let me zoom in. Head over to the kite. So we draw another kite. Terrible. So our opposite sides are going to be these sides. Okay, and then it says one pair of opposite sides are bisected. Okay, so it's going to be the opposite sides that are then going to be bisected. So again, this is A, B, C, and D. A and C are going to be opposite sides that are congruent, and that's going to be our opposite two vertices where you're going to have a bisector. So angle ABD and angle CBD is going to be congruent to angle ADB, and then angle ABD is going to be congruent to angle CBD, and then angle ADB is going to be congruent to angle CDB. Okay. Then the main diagonal is bisected. Okay, so this is our main diagonal. It goes between the two vertices where we had our congruent sides. So it's bisected. So this piece is congruent to this piece. If we had an E here, so let me again draw it out individually. Okay. So these are our congruent angles. So our main diagonal is going to be AC. So if we have A, B, C, D. Okay, and we know that the main diagonal is bisected by the other diagonals. So we call point E, we're bisecting. This is point E. We're bisecting it, so we're bisecting AC, so AE is congruent to EC. Okay, and the last one is that the diagonals are perpendicular. So we know perpendicular lines form right angles. So we know we're going to have 4 right angles. That is a kite. Okay, so I'm not sure if this was the most useful video, but it's out there if you guys need it. Again, we want to make sure everyone's on board with us. Test scores and scores in class, right, are very bipolar. We have a lot of good scores, a lot of bad scores, and we want to make sure I have something on there for you guys, for everybody. So this video is probably better if you're someone who's struggling and not understanding some of the vocabulary that we've used in the past, because this vocabulary is just piling onto itself. So go back and rewatch parts of the video that you don't understand. Okay. If there's vocabulary you don't understand, ask me, email me, let me know. We want to make sure everyone's caught up and everyone's on board with us for Unit 4. So we do better on this unit than the last one.